Hi. I'll be sharing technical knowledge received over a period from various gurus and sources. The purpose of sharing this knowledge is strictly for returning to my community, to whom I'm highly indebted. Mathematics of color change in plastics injection molding. Yes, you heard it right, mathematics of color change. What has mathematics to do with a subject like color change? Let's try and understand. Switching colors, or color changeover, is a necessary activity when parts are to be produced in multiple colors. A molder would always like to minimize the consumption of resources, be it polymer, pigments, power, or time. Practically, this has obvious behavioral patterns. Many a times, molders are of the opinion that they are losing a lot on account of color change. Let's therefore try to understand mathematically if what is considered as a loss is a problem, or is it a behavior? A problem would be generally a man-made one, and one can look for a solution to a problem. For example, usage of worn-out screw, barrel, nozzle, etc. Usage of inferior pigments or dyes. Behavior. Behavior resulting from selected system specifications. This is where the mathematics comes into picture. Given the specifications of the equipment being used, the outcome is only a resultant of the system specifications and need not be considered as a problem. Listen further. Interpretation of system specifications. Here, we'll be considering the color change activity as pertaining to the polymer residing in the system at any given instance of time. As such, we'll be just adding up the numbers and not indulge into any polymer or pigment behavior. So, how much polymer is there in the system at any given instance of time? Listen further. Part weight. This is the weight of the individual part being molded. If there are multiple cavities, part's weight is to be multiplied by the number of cavities. To this, add the weight of the runner. If this is a cold runner, just add the weight of the runner and sprue. If this is a hot runner, or a partial hot runner, add the weight of the cold portion of the partial hot runner to the weight of the polymer, which is always there in the hot runner manifold. Having done this addition, now we have the overall shot weight. We must understand here, shot weight and shot capacity are not the same. Shot weight is what we understood just now. Shot capacity is the maximum weight of polymer that can be injected by the injection screw when dosed to the full stroke length. Listen further. Let's understand how much polymer is residing in the barrel at any given instance of time. Polymer residing in the front portion of the injection screw. If the screw has completed the charging stroke, this is, at least, the same as the overall shot weight. Polymer also resides in the injection screw flights. Overall barrel capacity will be more than overall shot capacity. How much? This is best known from the injection molding machine manufacturer. Why does one need to know such mathematics? What has it got to do with the basics of color changeover? Simple. The amount of polymer that resides in the system at any given instance of time is the amount of polymer that must be replaced before you can have a complete color changeover. In other words, the amount of polymer you have added is the amount of polymer you have to delete to get a null value. This polymer is polymer residing between the hopper throat and the nozzle tip. Polymer residing in the hot runner manifold, if it is a hot runner type mold. However, this will just be a replacement of existing polymer. Purging out to achieve a complete color changeover will be in addition to this basic polymer content. However, this is not a part of this discussion. Coming back, we need to understand polymer that needs to be replaced, I repeat, replaced, depends on the selected system specifications. As such, this must be considered as part of the system behavior, I repeat, behavior. Meaning, polymer to be replaced divided by the overall shot weight is a minimum number of shots that must be accepted as system behavior. Do not consider this as a problem. This is simply a system behavior to be understood mathematically. Behavior of pigments and dyes. Various pigments and dyes will behave differently, and the color changeover will vary depending upon the intrinsic properties. As such, a longer or a shorter color changeover on account of pigments or dyes need not be considered as a problem, rather, it is a behavior. The present discussion is mainly mathematical. As such, this behavior is not a part of this discussion. To conclude, a molder must always bear it in mind that polymer replacement, when switching over from one color to another, is a behavior and not a problem. I have made an attempt to increase awareness. Your valuable feedback and suggestions are highly appreciated. Do subscribe to my YouTube channel for further updates. Thank you.